Hi, I got an interesting problem. I bought those LED lamps for growing plants. See what happens when I try to turn them on. They flicker. I don't know if you can see this, but they flicker. Only on some chargers. Let me show you this way. Maybe you will see. No, not this button. It's hard to do with one hand. Yeah, they flicker. But when I turn them on by pressing this button and then this one, then they work. And then they start to flicker again. But if I connect a different charger, yeah, then they work okay. Why? Let's see what the USB meter says. Interesting, right? So maybe there is an overcurrent. But on this charger, there is no overcurrent. So let's do it differently. Let's try bench power supply. I don't know if you will be able to see it. I hope so. Let me turn them on. Well, the constant current LED. Maybe they are drawing, but let's increase it. 2 amps. It still blinks, right? It's interesting. Why does it blink? I increased it to 5 amps and it still blinked. I don't want to do it now because I don't want to kill the transistors. So it blinks, but it draws only 1 amp. And the current is set to 2.5 amps and the constant current blinks. What does it mean? Is that it introduces some shorts. But when I when I dim it, it stops introducing those shorts. Okay, so how it actually works is that it has a full bridge here on those 4 transistors. When I connect it in one polarity, only white LEDs light up, and in the other polarity, red and blue LEDs light up. So we have a full bridge here. There should be some dead time to prevent overshoot. It's not overshoot really. To prevent both transistors, both sides of the bridge from conducting at the same time. Let me draw it to you for you. So this is one possible way to do the bridge. And you drive those transistors in a cycle. So it's either this way, so those 2 are conducting, or those 2 are conducting, so the current goes this way. And then both polarities of the LEDs are active. But what would happen if those 2 transistors were conducting at the same time? So for example, if this one was turned on before this one had the chance to turn off, then you would have a short. And I believe this is what's happening here. Well, this is some proprietary chip here, and by the way, this is the case for it. This is some proprietary, oh my god, the English is so hard, chip without any marking, because why? But I think maybe there is some resistance to set that time. Maybe it's this resistor, or maybe not, probably not. But what I'm going to do is just throw out this chip. I don't need any regulation, so I will get rid of those buttons and those LEDs. I won't connect them. I will just use some microcontroller I have lying around. Well, I have one here, but it developed an interesting problem. That's another story. And I will just write some software to switch it with some generous dead time, and I believe it will solve the problem. And to answer the question why does it work on one charger and doesn't work on another, well, I believe one of them has fast acting overcurrent protection and another one doesn't. That's the secret. But I don't want to keep it this way because, well, those spikes aren't supposed to be there, so if I use a charger on which it works, I will blow those transistors eventually anyway. And to answer the question why does it work correctly if it's dimmed, well, I believe there's a PWM here, apart from driving the full bridge, and then it just doesn't happen because you're driving. Let me draw it. This is just my guess. They are driving it this way without a PWM, so in those moments both transistors are conducting, but they might be driving it, for example, this way with shorter pulses in PWM mode. It's just my guess. I didn't measure it. And by the way, if you're interested, those are the transistor symbols. And yes, I'm recording the screen because I'm too lazy to grab my proper macro camera, so I'm just using something like this. And actually I was right. Well, this is the PWM signal. Let me zoom it. When I increase the brightness, no, now I decrease it, I increase it, and see what happens now. Well, it's out of sync because it's out of sync, but yeah, there are some. Yeah, you can see there is no dead time here. There is no dead time. That time should be trigger menu, not out. One moment. I don't see what I'm doing because I'm holding the phone and it's on the second channel. Yeah, because of those spikes I cannot really synchronize it. Yeah, you see? This is the signal. The dead time is too low. But when I decrease it, then it's just fine. Yeah, let's do it this way. Let me maybe show it to you this way. Trigger here, trigger line should be here. Yeah, so now you see there is no overlap. There is no overlap and it works. And now it doesn't. And I set the trigger wrong, but you know what I mean. And well, normally I would do it on at 80 Tini, but I'm out of 80 Tini 13, which would be perfect for this. But I have this peak laying around, so maybe let's use this peak. Well, it's large, but it doesn't matter. I mean, it's deep, but it will be easier to program it then. Right, so this is the microcontroller we'll be using. Well, it has been connected with just some random cables. Let's program it. It's programming and it's programmed. And that's it. Let's test it. So this is the code. Really simple. I just relied on a slow crystal oscillator because I couldn't get the internal RC oscillator to work, since there's no internal RC oscillator in this chip and external didn't work. This is how it looks. Well, not bad. Let's do some measurements. So the on time of one channel is 1.34 milliseconds. I don't know if you can see this. On time on another channel is the same, and let's measure the dead time. 360 microseconds and 100 and I don't know if you can see this, 120 microseconds. It should be enough. And if you're wondering why it's not even, because well, the crystal is so slow, it's 32 kilohertz. So actually when it jumps back here, so when it does the loop, it takes some more cycles, so here the dead time is slower than here. And actually, you know, I don't like big microcontrollers, and every project I make with them, well, right now it's a second one, but I made some other things, small things in the past. The less I like them. I really like AVRs. 80 mega, but I don't have any spare link around right now, so I have to use this big. Alright, so this is my Frankenstein. Those two capacitors are 33 picofarads for stability. This is a clock resonator, 32 kilohertz. This is a 100 nanofarad capacitor for stability. And well, those are the oscillator input and output, and this is the master clear, which has to be tied to the power supply, positive rail. This is the negative rail, and those two are the outputs. Well, it's not the best thing I did in my life, but maybe it will work. Okay, the sandwich is ready. And now testing time. Well, it doesn't work. It flickers in a different way. Let me show you on the oscilloscope. Well, there are some voltage spikes. The upper line, upper trace is a power line near the peak microcontroller, and the lower line is one of the outputs. So we can see the voltage drops and the peak doesn't like it. And now, after adding some random diode and a random capacitor, if you can see this, I can see what I'm showing. Well, actually not so random diode, because an ultra fast diode. It works. It works. And this is the current draw. Well, it could be higher actually. Yeah, this is the limit. I don't like it that I cannot quickly exit the editing mode, setting mode, so I can see the current again. Maybe you know how to do it. And before we go, if you're curious, this is the trace. This is the trace of the output, so we can clearly see the dead time here. This is one polarity, the dead time is here. This is another polarity, the dead time is here. And it's enough. The limiter doesn't kick in. Let me limit it even more. Oh, okay, now it does. Yeah, because it's because this current draw that you will see right now is the average draw with the dead time included. So the momentary draw is higher, it's around 1 amp, as we measured before. So well, the dead time could be made a little shorter, but I believe it's okay this way. Alright, well, thanks for watching.